Hi Year 10s, this video is to help you get prepared for your egg drop experiment that's coming up this week. It's going to go through a bit of a simulation that will show you a bit of the physics behind the egg drop, and hopefully it'll help you design your packaging and also answer some of the questions coming up. So the goal for this experiment is to create a package that's going to protect your egg when it's dropped from a height of 6 meters. So obviously your goal here is to have your egg survive unbroken. Now the winner of this task, if we can say that, will be the group that is determined to have a surviving egg with using the least amount of packaging. And the reason we have the least amount of packaging becomes evident a bit later on. Now the physics behind the egg drop has entirely to do with Newton's second law, which we all know by now is the force equals mass times acceleration. So if we remember earlier on, we were learning about acceleration being a change in velocity over a change in time. So if we plug that into our Newton's second law, it'll help us see that the force exerted on the egg is proportional to the mass of the egg multiplied by the change in velocity over change in time. Now it's these two factors, the mass and the change in velocity, that we use to actually help save our egg. Now I'm going to switch to an interactive here that I found on the net, which is actually really helpful. What we're going to do is simulate the egg dropping under a variety of scenarios. So first we're going to change our settings to a large egg, which is 60 grams, which is about the egg we'll be using, and drop it from a height of 5 meters, which is as close as we're going to get to the 6 meters we're actually using. Now the differences we can do here is the landing surface. Now this will help us determine the effect of cushions or crumple zones on protecting your egg. So if we just drop this particular egg onto a hard floor, let's run our trial, and you can see over here when I drop the egg, this is our egg dropping from 5 meters high, and you'll see it smashes completely to the ground. Now that's pretty expected, but what isn't expected are some of these numbers. Now, if you're dropping an object and letting it free fall in gravity, you know that hopefully the acceleration due to gravity is 9.8 meters per second. So over that 5 meters, the egg actually at the point of impact is traveling at a speed of 9.9 meters per second. Now, when the egg hits the ground, it has to transfer from 9.8 meters per second to 0 virtually immediately. In fact, in this simulation, when it drops directly on the ground, that change in velocity from going from 9.9 to 0 occurs over a time of 0.003 seconds, virtually nothing. Now, if we actually plug all of those numbers into our Newton's second law equation, our mass times our acceleration, we end up with a force enacted on the egg of 198 newtons. This obviously is enough to break the egg. Now let's change some of these conditions to see if we can save our egg. Now what we're going to do is change the landing surface to a 1-inch piece of foam. I'm sure you all know that foam is quite squishy, and if you drop something on it, it tends to cushion the impact. How it works in this, you'll see in the simulation. So what we're going to do is run the trial again with a different surface. So we're going to see our egg dropping again onto the 1-inch foam. This time the egg survives. Now if we look at our numbers, it's pretty clear why. Now the velocity of the egg is exactly the same. It is still falling from the same height, it is falling for the same amount of time, so the speed at which the egg is traveling when it hits the ground is still 9.9 meters per second. What's different is that it hits the foam first, and so it has that little bit more time. In fact, it actually has 10 times the duration from when it hits the top of the foam to when it impacts the ground beneath the foam to actually slow down from 9.9 meters per second to 0. So the time it took to actually slow down and stop is considerably longer, and look at the effect it had on the force. This force went from about 198 newtons to 19.9 newtons. That is a reduction of over 90% of the force enacted upon the egg simply from a 1-inch piece of foam. Now because the force was reduced, because it took so much longer for the egg to slow down and stop, the egg's now safe. The force isn't enough to break the egg. Let's change our conditions again and make it even more ideal. Let's give it a nice foam box. This could simulate in a way the packaging that you can use. You won't have foam available, but you'll have a lot of resources at your disposal to try and help your egg to survive. So let's drop him again from the same height, this time dropping onto an entire box of foam. And I'm pretty sure you can guess that the egg survived again. The velocity is still the same, and look, the time is actually double. It's gone from 0.03 to 0.06 of a second. So the egg is now taking even longer to slow down and come to a complete stop when it hits the surface. Now because the time is even longer, and its resulting force is now 9.9, so it's about half of what it was. So the story basically shows that if you're going to slow down the time it takes for the egg from the time it hits the surface of the ground to coming to a complete stop, if you manage to slow that down enough, you will save your egg by reducing the force. So there's a couple of ways to focus on this. Obviously, increasing the deceleration time or increasing the time it takes for the egg to come to a complete stop. That can be done by crumple zones within your packaging. The other thing you can do is to decrease the mass of the egg. You can't actually decrease the mass of the egg itself, but if you're using less packaging, you have a less total force because you have less total mass. So this is where it comes into play that you really should be trying to use as least amount of packaging as you can. More is not necessarily better. Sometimes it is, it really depends on your design, but if you can get away with not using all of the materials at your disposal, you'll reduce your mass, and hopefully that will also act to reduce the force. Now if we go back and look at our numbers again, just to get a nice summary of what happened in those crumple zones, you can see that as you increase the cushioning or increase the crumple zone available to the surface, you increase the time it took the egg to come to a complete stop once it hit the ground, and as a consequence the force decreased substantially. So please keep these in mind, especially when you're answering the discussion questions. I hope this video helped out. If you've still got questions, please email me and I'll see you in class.